so today we are going to introduce a couple new theorems for finding angles using the lines in or on our circles. Okay? But in order to do that, we need to introduce one more type of line. Okay? The first line that we'll be introducing today is called a secant. Okay? So a secant is a line that intersects a circle in exactly two places. Okay, so in this drawing over here, you can see that it's basically a chord, because a chord also should intersect the circle in two places. But unlike a chord, it keeps going outside of the circle. Okay. So a chord would have stopped at the edges of the circle because a chord is a segment. A secant is a chord with arrows. Keeps going. Okay. All right, so now that we know what a secant is, let's look at a couple new theorems that use secant lines. Okay, so the first theorem says that if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so it said that we would have a secant line, which would be like this line TR, right? It intersects the circle in two places and continues outside of the circle. They also said we would have a tangent line. That's what this one down here is, VW, right? A tangent line touches the circle in exactly one spot, so it's not going to go inside the circle. Okay, it says if these two lines intersect at the point of tangency, which they did, right, they intersect at point T, then the angle that is formed by those lines is 1/2 the measure of its arc. Okay, so kind of the same rule as last time. If you half the arc, then you can find the angle. Okay, so they have this picture drawn for us, and they give us a couple of examples to work through here. Okay, this first one says if the measure of the angle RTW, that's this angle here, is 50 degrees, then they want to know the measure of the arc RT. Okay, well, normally they give us the arc and we half it to find the angle. This time they gave us the angle, so what can I do to find the arc? Very good. So if the angle is 50, what's the arc going to be? Very good. Okay. All right, on the next example, still looking at the same figure over here, but now they say the measure of that arc, RT, is 86. They want us to find the angle. So now they gave us the arc, we find the angle. So what are we going to do with that 86? Right. And what is 86 divided by 2? 43. Okay. So now I know that this angle is 43. All right. Okay, they also want to know the measure of the angle VTR, or RTB. That one right there. Okay, well, what do I know about those two angles? Yep, they're a linear pair, which means, I heard somebody else say, supplementary angles. Okay, well, if I know that one of them is 43, what does that mean we do to find the other one? Just subtract. Good. Okay, so remember, they're on a straight line, they are a linear pair, and therefore are going to add up to 180. So you can subtract 43 to find the difference for that outside angle, RT. All right, everybody have all those before I change slide? Okay. All right, our next theorem says that if two secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the vertical measures of the arcs intercepted by the angle and its vertical angle, similar to finding the average of the arc measures. Okay, so this time they said you're going to have two secant lines. So that's what we have here. Secant line TR, secant line SU. Okay, they have to intersect inside of the circle, which these do, right? They all intersect at this one point right here, which is inside of the circle. Okay. They said that what you can do to find the measure of the angle between those two lines and its vertical angle, because we know vertical angles are very good. What you can do is take the measure of the two arcs that it intercepts. So that would be the arc ST, right? And the arc RU. It says you can take those two arcs and add them together and then divide by 2, and it will give you the measure of those two angles, right? Angle 3 and 1 will be congruent because they are vertical angles, okay? So adding this would also give me the measure of angle 1 as well, okay? All right, so now that we kind of understand the rule, they give us a couple of examples to try it with. So they first said that the measure of the arc ST, this one here, is 30. And the measure of arc RU down here is 80. They want us to find first the measure of angle 3. So what would I do with the 30 and the 80? Add this, and then, right, and what does that tell us angle 3 is going to be? Very good. Okay, so I'll put that here in the blank. So now I know angle 3. They also want angle 2. Well, what do I know about angles 2 and 3? Linear pair. So if this one's 55, what could I do to find angle 2? Right, subtract. Very good. All right. So angle 3 is 55, meaning angle 2 is going to have to be perfect. Okay. Do they have one more example for us? This time they tell us that the arc up here is 30. Okay? Angle 1 is 50. And they want us to find RU, this arc. So we would just plug it into the same formula, right? But you would have a 50 here, and then a 30 here, and an X here, right? But you would still just solve using the same formula. And I already heard somebody say what it should end up being. What do we get? Not 40. Yes. Good. Okay. Because we should have 50 equals 30 plus x divided by 2. So how would I get rid of the divide by 2? Multiply. So then I would have 50 times 2 over here, which is 100, equals x plus 30. Subtract. 100 minus 30 is, there we go. All right. Okay. And then our last theorem is going to work if you have two secants, a secant and a tangent, or two tangents. Okay, so this one covers a wide variety of cases. Okay. It says if you have any of those combination of lines, they intersect in the exterior of the circle. So outside of the circle is where the lines cross. Then the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arcs. Okay? So when they say positive difference, difference means we are doing what? Subtracting, right? And if I want to make sure I get a positive number when I subtract, I should have big number minus small number, right? So make sure you always do that when solving a problem using this formula, okay? Okay, so, oh, sorry, didn't put the words in there. So exterior, 1/2, and intercepted arcs. So the way that would look is in this figure right here, case 1, this has two secant lines, right? Secant lines are the ones that touch the circle in two places. They do intersect at this exterior point A, so they follow the rule. It says that you would then get the positive difference of its intercepted arcs. So remember, the intercepted arcs are the arcs between the lines, right? So that would be this arc and this arc, because they are between the lines. If I want the positive difference, we said that meant the big one minus the small one. Well, visually, you can see the big one would be CT. So you have CT minus the small one, BR, divided by 2 is going to give you the measure of this angle out here. Okay? Same rule applies if you have one secant and one tangent, like this picture here. One secant line, one tangent. You still are going to take the difference of the intercepted arcs, so that would be this arc and this arc. Again, visually we can see FG would be the bigger one, so we do FG minus EG divided by 2 should give me the measure of this angle out here. All right, and the exact same thing if you have two tangents, all right? So I've got two tangent lines. The big arc goes all the way from I to J, and then the smaller arc goes also from I to J, but in the short direction, all right? So this would be a major arc over here. This should say IXJ. And then the measure of the minor arc is just IJ. And again, you divide by 2 to find the measure of this angle out here. Okay. So same rule no matter what kind of lines you have. 2 secants, 2 tangents, or a secant and a tangent. Okay? Alright, so now that we have gone over all of these theorems, let's try a couple of examples using these rules. Okay, so example 1. It says in circle Q, the measure of the angle CQD, this angle right here, is 120 degrees. They also tell us that the measure of the arc BC, which would be this arc here, is 30. And the measure of the angle BEC, this angle here, is 25. And they want us to find these 4 measures. Okay, so the very first thing they ask for is the measure of the arc DC. So what should it be? Huh? Not 240. This angle is not on the edge of the circle, is it? This is 6.2 right here. The measure of the central angle and the measure of the arc should be what? The same. Okay? The measure of the arc AD. Okay, well AD would be this arc here. Okay, so that is the intercepted arc of these 2 secant lines, right? Okay, so we had the formula for that on the bottom of the front page. What was the formula for finding that? Big arc minus small arc. Well, this is the big arc. Do we know what it is? So that's going to be our X. Minus, what's the small arc? Good. Divided by, should equal the angle. And what's the angle? 25. Okay. And then we just solve for X. Right? So what will we do first? Multiply by 2. So I would have X minus 30 equals 50. Then what? Add 30, so what is X? Good. Alright, so now I know that this arc is 80 degrees. Okay, now they want to know the measure of this arc right here, AB. How could we find that? So we got 80 and 120, which is 200. plus 30 is 230. And then what do we do once we've added them up? And what's that going to leave us with? Very good. All right, so now I know this piece is 130. And then the very last thing they ask for is the measure of the angle QDC, this angle right here. Okay, well, what kind of a triangle is this right here? Isosceles, very good, because we have 2 radii for sides. Well, if it's isosceles, not only does it have 2 congruent sides, it has 2 congruent. Okay. So these 2 angles are the same. 120 is taken up. What does that leave for those 2 angles? 60 to share evenly. So each angle would have to be. Good job. Okay. So this one had us using new rules, old rules, really old rules. We know that it's triangle's 180. All right. Okay. So now we've got all of those solved. Okay, so now looking at the next example, it says to use circles K to find the value of X. Angle R is formed by a secant and a tangent. So again, that secant, tangent, or 2 secants or 2 tangent rule from the bottom of the first page. Okay, again, you guys already told me that rule is big arc minus small arc divided by 2 equals the angle. Well, they kind of already helped us set that up here, right? So big arc is the one that's highlighted in blue, right? So they wrote that down first. Minus the small arc, which is the one in red, divided by 2, should equal the angle. They said the angle was x plus 2.5. Okay? So, what would I do first to solve this? Got to multiply both sides by 2. So, over here, the 2's will divide out, but over here, make sure we multiply both of our terms by 2, both the x and the 2.5, right? Then we start combining like terms and moving things from side to side. So what do we get for x? Very good. All right. Any questions on that one? All right. Then the last one, again, same idea. This time we have 2 tangent lines. So what's going to be the small arc on number 3? Y. Okay. The big arc would also go from W to B, but the long way, right? So they didn't tell us what that piece is, but we know a whole circle is how much? And how much is already taken up? Y. So the big arc could be called 360 minus Y. So we would have big arc, which is 360 minus Y, minus the small arc, which is just Y, over 2 equals 28. Okay, so what are we doing first? Multiply by 2, So then over on this side, I would have 360 minus Y minus Y. So 2 negative Y's, when we combine them, we just have negative 2Y, right? So 360 minus 2Y on the left. And what are we going to end up with on this one? Very good. All right. Any questions on how we came up with that answer? Everybody good? Okay.